All right, guys. So dilation means the figure. So this is still 9.2. This is kind of like the second part. Dilation means the figure gets bigger or smaller. If it gets bigger, we call it an enlargement. Okay, because guess what? It gets larger. Or we call it a reduction if it gets smaller, like reduce. All right, if you reduce something, you reduce the price, you made it smaller. Okay. So again, we have that fixed point called the center of dilation. So for these first couple, all we're going to use is the origin. Okay. So we're going to kind of keep it a little bit simpler. So dilation is an example of a non-rigid motion because guess what? The figure, the pre-image, and the image are not congruent. Okay. It either got bigger or smaller, right? So a dilation produces a similar figure. So think back to chapter 7 when we did similar figures and we used proportions to solve for missing sides and missing sides in the figures. Okay, so think about back to proportions. So all corresponding angles are congruent, remember, and then all corresponding sides are proportional. That's the definition of what a similar figure is. Okay, so review of chapter 7 a little bit. So the scale factor, we've worked a lot with scale factor. The variable we're going to use for scale factor and that you're going to see is K. All right. So K, just a variable, represents what the scale factor is. K is actually going to be a number in problems that we're working through. But just so we can get an idea of when the figure will be enlarged or reduced, when K is greater than 1, okay, a dilation is an enlargement. Okay, so I think, hey, the number's larger than 1, so the figure is going to get larger. If k is less than 1, if we got a small number, basically k is less than 1, that means that it is a fraction. Okay, so if you're given a fraction, k is less than 1 means the number is a fraction, then the dilation is a reduction. Okay, so moving on to our dilation rule when the origin is the center. All right, only when the origin is the center. This is how we're going to start off. We go from the coordinate x comma y to the coordinate k times x, k times y. All right, kx, ky. So if we look at this, sometimes I think with all these variables, it kind of gets a little bit challenging. But if we just look at our first example here, okay, we have RST and our k equals 2. So what we're going to do is we're going to take this. R is at negative 5, 1. So all we're going to do to find R prime is we're going to do 2 times negative 5. All right, and that's going to be our x coordinate. And then we're going to do 2 times 1. All right, so 2 times negative 5, that's going to give us negative 10. 2 times 1 is going to be 2. All right, so our coordinate for R prime is negative 10, 2. All right, that's all we're doing here. Okay, so really you don't need to graph it. Again, graphing it just helps you guys see the picture. So if you want to see the graph, they can do a way better job than I can on this video. So look on the notes key and you guys can see the graph. Okay, I just want to show you how to get the coordinates. So if we look at S, okay, so S is negative 3, so we're going to multiply that by 2. Actually, let's write it in the other order. So we're going to do 2 times a negative 3. It's going to be our new x coordinate, and then we're going to do 2 times 4. All right, so our coordinate for S prime is going to be negative 6, 8. Okay, so S prime, negative 6, 8. Alrighty, and lastly we have T prime, T prime, so we're going to do 2 times 2 and 2 times negative 1. Okay,